This
Please.
conference will now be recorded.
So is that you can see my screen, Dave? Yeah?
Yes.
Okay. Right. Good afternoon, everyone. Thanks for joining us, the section meeting. As Dave says, I'm the secretary for Liverpool and Manchester section. Also one of the track CREs on the Transpire project, or West of Leeds route upgrade, as it's being changed too soon. And the head of track for Tony G and partners, based in Manchester. So basically today we're just going to talk about the Transpire route upgrade section, which is W1A, which is miles platting, and just go through. I've kind of split it into so JTI, for those who don't know, stands for Journey Time Improvement, and it's where we look to kind of get the maximum speed out of the current track. So the project was overall is a journey time improvement scheme, looking to reduce the journey time between Manchester and Leeds and York. So I've just split it into, using those three terms, I split it into the journey, the time, and how that it's affected the project, and what we're looking to save, and then the improvements. So what the improvements are in this particular location, and then we will also just have a quick look at one of the aspects of the project, because as I started putting this together, I realised that we've been on it a very long time, and there's a lot that's happened in the 3 years that we've been doing it. So, quick overview. Obviously, Transpire route upgrade. I'm sure a lot of you are aware that it runs from Manchester to York via Leeds and Huddersfield, with the scheme split either side of Leeds. So you have west of Leeds and east of Leeds, and Transpire focused on the west of Leeds, and it's split into basically 5 separate projects, W1 to 5. This particular scheme sits in this tiny little bit just outside Manchester, Victoria, and obviously there's some major interventions going on throughout the route at Huddersfield and Morley and other areas to reduce the journey time. So this is the actual footprint. So this presentation also uses the BIM model, which has just recently gone online with some of the work that Jacobs and Andy Bone's been doing. We've now got the models live in a federated BIM environment, iModel, which is on the web, which has been great to do IDCs, etc., of all the disciplines combined in one place. So I've more or less taken all of the images out of that model for this presentation. So as you can see, we go from Manchester Victoria through the Manchester Victoria Junction, Collyhurst Ladder here, miles platting, which is where the majority of the time savings take place, and then we've got Phillips Park Junction, Brewery Curve, etc., in this Delta Junction here. And that's just the line diagram covering the extent. So it's about 2.5 kilometres from Manchester Victoria up to miles platting, and we're basically affecting more or less all of the down Rochdale Slow and up Rochdale Slow lines for the whole route, starting from about 300 metres from Manchester Victoria. And this is miles platting curve itself. I mean, this highlights some of the civils interventions. We're renewing a structure in Queen's Road and doing works on the retaining walls and the structures throughout here. So, but I've included this just to kind of show you where the time savings are in this curve, which is miles platting curve, and that's the existing curve, which was about 220 meters, I believe. Check rail jointed and limited to 30 miles an hour. So the journey, what is the journey? From Manchester Victoria, you come out of the station on the, as I said, the Rochdale slow lines under Cheetham Hill, and you're straight onto a viaduct, which is MVM6, with around about 40 spans in MVM6 for around 400 meters. So yeah, straight away we're on constrained infrastructure when we're trying to increase the speed, the line speed. From there, we have a constant gradient, increasing gradient up to miles platting, and the whole of the route is going to be electrified. Some of it already electrified as part of MWEP, and those construction works were still being carried out at the start of the project. So as I mentioned, it's on a viaduct MVM6 for the first 500 meters. Well, for about 400 meters. Under bridges, got over bridges to contend with. We've got a shallow depth tunnel, which the Metrolink runs through and passes under the track. We've got longitudinal timber structures which we need to leave in place at Bromley Street, which is a subway that we had to maintain. We go through a cutting with retaining walls. They've been there a long time, and we're adding in a new underbridge, or replacing an underbridge for the alignment, and building a new embankment for the flatter curve. So talking about the structural restrictions, the alignment, I mean, it's pretty hard to tell the previous scales, but it does snake basically out of Victoria, and it's constantly reversing, and we think this is probably due to, for historical reasons. The structures are as old as you'll get on the railway system, and there's a mixture of steel decks, arches, Gothic arches, a whole host of structural types through that viaduct. And what that means is as the alignment is, as I say, reversing through the structures, because this structure MVM6 has been expanded throughout the years, obviously to cater for more tracks. Any movement of the track off these supporting structures can potentially cause problems where they need reassessing or strengthening or replacing. So we've had to be very mindful of that when we've been trying to increase the speed. Initially, we had huge sloughs, which we had to reduce to prevent incurring huge costs in terms of civils works in repairing some of these structures. And one of the big restrictions, which is still a risk on the project, is through the Gothic arches, they have these chutes. We think the drainage chutes, we're not 100% certain. On the left there, we can see one of the original drawings, which kind of details these chutes, which isn't great. John Gocher and his team have kind of recreated these to try and locate where they are. And unfortunately, when we have, these are guesses, where we have located them, it looks like they're under Manchester Victoria East Junction, and this is some of the S&C we're replacing. So there is a concern that underneath the track bed we have these chutes that are sticking up at the crest of the arch, and also in between the Gothic arches. We haven't been able to find any that we know of. We've tried digging in the cess to locate some of these, and they haven't been found. And this junction was remodeled in 1997, I think, but I haven't been able to find any historical information where they've either reduced the height of the chutes, or they've been removed or infilled, or what. But what we do know is when we were drilling a core in one of the chutes at road level, one of the guys drilled through on the chutes, and it released an outpouring of water, which I'm not sure how long it's been there. The immediate thought was, oh rubbish, we've hit a pipe. But yeah, it soon stopped, and it turned out to be one of these chutes that we'd hit. So they are still there, and as I say, it's a risk that we're having to manage when we go in and replace the S&C. So the project journey. So as well as the project itself and what we're physically doing on the ground, we also have the actual journey of the project, and it's been 3 years now since that we started, that we've been on the project, so just over 3 years. And we've gone from grip 3, which was option selection, where we came up with 12 different options for the W1A footprint, which looked at achieving 60, possibly even 70 miles an hour around the curve. And it was all narrowed down to the current option, which is the least intrusive and doesn't affect things like Hollyhurst ladder. And the option selection report went through an expert panel, and this was the option that was chosen in terms of renewals and improvement to the track. So the interesting thing about this project is it's TRU that are defining the scope. So we're telling Network Rail, or originally we were telling Network Rail what it is we're going to be doing to gain this journey time saving. Okay, so the speed, initially we were using the tip model, which I believe has been developed by Kev Mellor and Ian Ellis amongst others, to kind of quickly calculate how we're going to, or how much time we can save by the interventions. And this miles platting is currently 30 miles an hour around, obviously a tight curve of, say, about 220 meters. So this produces this dip in the existing line speed profile, which is shown in blue here. And what that means is, obviously, the vehicles are coming out of Manchester Victoria East, Manchester Victoria. They're accelerating up the hill, and then they have to brake to go around the curve and then start accelerating, and that has a huge impact on the speed, especially on the downline as they're accelerating up the hill. So the plan is to actually this speed profile I've picked actually shows us doing 60, so it's been superseded since then. But basically, we need to remove this, which allows the vehicles to constantly accelerate all the way up to an aspirational speed of 75 through Bagley Fold. So that's the idea, and then we're off onto the through Ashton and Clayton level crossing at 75 miles an hour, and that's just by removing this 30 mile an hour dip. We're saving something like 43 seconds with the fastest vehicles, which for the scheme is a lot. Basically, it doesn't sound like a lot. So 43 seconds isn't going to change your day, but overall throughout the scheme, gaining any seconds on this like heavily constrained route between Manchester and Leeds is very difficult to do. Freight is still restricted at 30 around, especially in the up direction, just because it's obviously downhill into Manchester, Victoria. So signalling deemed it was necessary to keep that as 30. It's currently 30 for them, and they obviously have a slower speed profile going down the hill as well. Exceptional values required to achieve this without ripping out every single structure around the curve. And we can talk about the constraints on the curve in a second. And then this was originally one of the best cost per second schemes. So as I said, it's very difficult to gain seconds on this route, but this was deemed one of the best in terms of value for money, when we were just purely looking at adjusting the alignment and obviously just removing the one structure. So as we increase, obviously to save time, we obviously have to increase speed. To increase speed, we then may compromise on passenger comfort. And this is one of the first projects, certainly that I've come across, where we've considered passenger comfort modelling. And this was carried out by Huddersfield University. who joined the project kind of at the grip 4 stage, and I've done a lot of, or have a lot of experience in modelling the passenger comfort. And the way they did this and produced the report analysis for W1A, which is the first to go through through the process, is they basically take some equipment, I can't remember what it is, accelerometer, etc., on a train, in this case the 185, and they do the journey several times with this box, and they record where the vehicle is causing discomfort, basically. So if you feel it like, you know, swaying or jolting suddenly, then they record that with a box. Then they go back and analyze the existing track, which we already have the survey for, and then they analyze the design to say whether it meets the guidelines. And there's different guidelines. There's European guidelines for passenger comfort, which is what this was assessed against, and there's Network Rail guidelines, the European ones being slightly harder to meet. And basically what these graphs show is they combine, so this first graph in the top left, this is showing, I'm just trying to think what's the difference now between the two. So you basically have, this is the existing data with the irregularities included, and it's showing that the existing axles and how they're recorded, and then with the modified, when it talks about the modified, so it's either side of the line, it's that's the proposed design that they've projected with the irregularities, projected the modified design, or sorry, our proposed design, and it's given the values. Now, this was deemed to be, or deemed to have good ride quality. However, once we add the irregularities which are in the track today, because this is modelled without the irregularities, this is just pure survey or design, and you can see it's much smoother. But when they use the irregularities which are detected by the equipment on the train, then it shows that yeah, it's a good ride quality when you model it perfectly, but if you start getting irregularities in the track, then we could be into poor passenger comfort or medium passenger comfort. So what they actually recommended as part of their report is that the track has every possible chance of maintaining its alignment via good track bed, LRPs, etc. So, and good maintenance. So that's a little bit on passenger comfort. It's obviously been covered in a separate presentation, but that's a quick overview of how it affected W1A. And here's Miles Platting curve. So again, this is taken out of the BIM model, which kind of shows the curve. I mean, it's kind of hard to see how tight the curve is, but just to give you some idea of the constraints, what we have here is the new structure, which we've had to change to get the alignment. We've got Collyhurst ladder starting here at the end of the transitions, so we're tied in to how far the track can slew over here. We've got Collyhurst siding, which had to be maintained, and we'll talk about that a bit later on. Over this side, we've got Oldham Road. Can you see my mouse, David? Yeah. Yeah.
Yes, I can. Yes.
Yeah, thanks. So on this side, we've got Oldham Road, which is a box girder bridge. It's actually two decks here, but we obviously can only go over one, because just off the drawing here, we have Bagley Fold Junction, or Firms Park Junction, sorry, which is linked to Brewery Curve, which we talked about earlier. So again, this is transitioning in off the curve over the structure, but we've managed, we've had to lift the track as well, but with the lifts and the geometry, we've managed to just get through the structure with clearances of around, lower sector clearances of about 75 to 100 mil. So it's tight, it's heavily constrained, and everything on this curve is pushed to the maximum, and that includes cant, which is 150 mil. We have deficiency of 140 mil, which is obviously exceptional values, and because of that, special agreement from the RAM, we've done track X analysis, we've looked at the geotechnical aspects of the embankment. So everything is considered for this curve, and we've reduced the sleeper spacings to 600 mil to help with CRT. It's got LRPs to maintain the alignment. There's lateral resistance plates. Obviously, it's got USPs and sleeper pads on the sleepers. We have had to use some short-ended sleepers on the structure, just because it has got so tight. As I said, everything is pushed to the limit to get the 55 miles an hour speed. So we also have used geocells through parts of the embankment where the old embankment is, where it overlaps the old embankment, just to make sure we've got a constant track stiffness under the bridge. So yeah, lots of consultation on this curve, but one of the remits of the project is to push the limits and push the standards to get the additional speed, and that's exactly what we've been doing here. And that's Oldham Road Bridge again. Phillips Park Junction is just off the drawing, but this is as you can see, the box girder. The track, we've actually modelled the track bed and formation, and it allows us to take sections through structures, etc., and see where we're getting ballast depth issues, or if there are ballast depth issues. But you can see where it tucks in, where we've had to put in short-ended sleepers. So the project time. So as I said earlier on, the time saving was driving the scope initially, with asset resilience added more or less as we got past option selection. So it was a bit of a curveball for W1A, which has kind of been ahead of the rest of the project because it was an easy win. It was pushed forward and kind of accelerated, but it meant that, as well as resilience being added, so resilience, they were talking originally about 2030 and no interventions until 2030, but as well as that, they also the requirements of the project were still being developed, so they were coming in as we were starting Form A, and they're still coming in now as we're just about finishing Form B. So we're a bit ahead of the rest of TRU. So the improvement. So how are we improving the track? So yeah, there's been a track category increase that was coming anyway, but this project does increase it further to track category 2. So because of that, we are replacing the ballast and sleepers. There's a lot of mixed sleepers, steels, concretes, timbers throughout the route, various types of concretes. So we're replacing all of those. Just because of the location of the track that we're replacing, and when we replace the ballast, it's probably easier to re-sleeper rather than double handling all the sleepers on and off the route. 4 new S&C units that have poor alignment and poor componentry, which were installed in the 90s at Manchester Victoria East. We're now using the rail vac to replace the ballast under the Collyhurst ladder. We've got improved alignment and increased reliability with these changes. New structures, Queen's Road, as we mentioned, new electrification or additional electrification. We're renewing the sidings, and we'll talk about that in a little bit. And the new embankment, obviously, around the curve. So overall, we're improving the railway a lot. There's a lot of renewal going on. There's been no compromise to access or safety. And this is Queen's Road. This is Queen Street, Queen's Road. This is the new structure that's being put in. It's using some of the existing abutments to make some savings. So it's just a new deck on a slightly different angle. You can see where the original deck used to run alongside one of the current decks, Queen's Road. So yeah, that's being replaced, and we've got stiffness transitions where it goes onto the new embankment. Stiffness transitions for all structures actually, but this one in particular uses geocells to make sure that the stiffness is uniform across the as it leaves the bridge. That's my Danzig Street, so that's just another structure that's been replaced, which is in very poor condition at the moment. So as part of these works, that's been taken out and put back in, which is going to be pretty tricky with the OLE and its current location. So just a few lessons to kind of highlight before we talk about Collyhurst the buffer stop issues that we've had. And it's quite interesting as I was reflecting on this. I mean, when we've done JTIs in the past, we've always consulted the RAMs at so we did the JTI for Northern Hub, and Scott McKevitt was very much involved in the process and how we should carry out JTIs. And one of the initial things you start doing when you look at the route from a very high level is where you're doing interventions or increasing the speed, it's good to kind of get an understanding of what the existing track condition is, or asset condition generally, so that includes embankments and structures, etc. Just to kind of get an overall feel of if you are increasing the category or the track category or the speed, what's going to be involved there. But TRU took a slightly different angle because of the length and the size of the project. We were looking at the route as a whole, really, and there was lots of, we were considering every single option to make sure that no stone was left unturned, from straightening out whole sections of track, to removing tunnels, to demolishing small villages, and not quite that far, but everything was on the table. So it was coming more from what's the absolute maximum can we get out of this track. So we didn't really consider the kind of route requirements until probably a bit too late, in my opinion. That might be a bit controversial, but so some of the issues that we had here. So Bromley Street is currently a longitudinal timber, replacing that with a FFU long timber. However, the maintenance has said we would have preferred just to direct fix that, and that's kind of come out recently, although it's been discussed in the past. MVE, we changed the scope from that. We were just putting a like-for-like S&C renewal back in there, and we changed that to concrete, and there's talk about adding additional units in whilst we've got the blockade, and we're renewing that parts of that junction. So that's come from maintenance and the RAM requirements. Collyhurst siding buffer stop, originally we thought we could just take that out, it's not being used. However, as the project started, the freight operating companies did start using it, replaced the track, cleared the vegetation, and it became quite a serious constraint on the project. And again, we should have probably known that they're about to reinstate that. Miles Platting curve, getting the TOCs involved, obviously passenger comfort will, it's good that we've done that piece of work, because obviously we can prove that the increase in speed isn't going to affect passenger comfort. Manchester Victoria East, S&C alignment shoots that we were unaware of initially. Well, we've been able to find since the scope change, as I've just mentioned, going from timbers to concretes. Staging, signalling are slightly behind in terms of the where they're at. They're at grip 4 now. We're at grip 5. So we're having to design all the S&C with IBJs that can be removed in a couple of years' time when they go to axle counters as part of the signalling project. And then, NR data. It's just it's pretty tricky when you're trying to obviously find things like shoots, historical data that should have perhaps been recorded 20 years ago when they did the renewals, but just kind of data that's out of date. I mean, we've had guys looking for pre-76 rail on this route that's been shown in Joggis that's clearly been replaced in the past, or it's magically disappeared. Asset age, a lot of the reballasting that's been specified in this project is based on Joggis, which may not have been fully up to date. So again, pretty controversial, I know, but it's having that accurate historical data is so important when you're looking at a scheme this size. Positives though, route view, really good for kind of stopping us going out on site and being able to just look at stuff, and it's up to date. So that's a really useful tool. And the data support tool, which kind of came online at kind of the grip 4 stage, which kind of brings a lot of the data together. My only criticism is with the network rail data is that it can be difficult to get hold of, and so having access to those records would have been very useful. Anyway, probably upset a few people there, that's fine. Collyhurst buffer stop then. So yeah, so obviously a few problems came up. Initially, this was the image from route view, which I just mentioned. So we were looking at that thinking, well, clearly, we can just remove those sidings, but they're not going to cause a problem. However, GB Rail Freight had different ideas, and we're currently in the process of reinstating that track and using that area, this lay down area here, for loading trains twice a day. So the standage, according to GB Rail Freight, was already too short. They could have done with a longer siding, so we couldn't reduce the siding for the new curve. Obviously, the curve flattens off around the corner, so it was looking to take this out. So that was a problem. We did a risks workshop, which considered every possibility, which kind of making this siding safe for the adjacent track pretty difficult, to be honest. However, we've been in consultation with Rowie and HJ Skeltons, who've given us some useful advice and their experience in terms of dealing with these scenarios. So that was really good. And then the buffer stop standards don't really take into account this kind of scenario, and why would it? Because who would put a buffer stop with a track immediately behind it? So we had to kind of go back to first principles with the help of HJ Skelton. So what we had originally, this is the buffer stop here. It's not a great section from the model. And if we left it in its current position, it was very close to this new curve. This was a lot further over in the original design or the existing design. And the buffer stop risk zone, which is primarily used for stations, which gives you the high, medium, and low risk areas of a derailment if it hits the buffer stop, didn't work. I mean, we were basically in a high risk zone. So the original buffer stop is around about here. So we had basically the high risk area of a train overrun through the buffer stop or derailment, affecting the new faster slow lines. So it was unacceptable. So we have been able to realign the siding by putting a curve and slewing it across, but it has meant we're going to have to reballast the track because it's just been reinstated by scabbling the existing track bed. So we're going to move the track bed over slightly, but it does create it maintains the existing standage for the tracks. And with the help of Skeltons, we've put in a sliding buffer stop, sliding friction buffer stop, and all this has been calculated for a fully laden train being pulled by a class 66. The movements of the train, they split it and then rejoin it. So that will be this is basically we'll stop this, but without stopping it dead, if you know what I mean. So it would basically the buffer stop absorbs the force, slides along with these retarders here stopping it. There is an embankment there. Well, hopefully we'll never get to that point. If the train is unladen, and this is why you normally have a lot longer sliding area behind the tracks, if it's unladen, then this will act as a fixed buffer stop, and the train will just stop if it rolls into it. If it's under power, it'll still act as a friction buffer stop, but if it just rolls into it, it'll act as a fixed buffer stop and won't move, because it's designed for forces of 1,220 tons hitting it at a speed of 10 kilometers an hour, which is the minimum speed you can assess, even though this will only run at walking speed. I think this is a type 16 ZEB sliding buffer stop. So yeah, it was quite a long process to get this agreed. And as I say, GB Rail Freight, if we could have just pulled this buffer stop 20 meters further forward, we would never have had a problem. But as I say, GB Rail Freight have been quite adamant that they need as much standage as they can get. So this is the solution that we've come up with. And there's just another view, and you can see that if the original buffer stop was over here, it's obviously in direct line of affecting these tracks. What has improved this situation as well is that this structure actually has robust curbs added into it. So the robust curb, obviously from this direction, but it would still work in the same direction. So if we did derail a train or we ran through here, it's not going to impact on the bridge, because the robust curbs will also act as a protection for the structure, which is nice. So the project improvement, so the W1A was ahead of the project's and system requirements, which made it very difficult. We were constantly having to go back and add or change aspects of the design. The JTI workflow, which I've mentioned, the resilience scope wasn't informed by the RAM, which may have meant that we've kind of done more than we should have done, and that came after we'd gone through option selection, which again meant a change in scope for us. NR records up to date, easily available, and survey resource survey has been difficult. I mean, there's a huge amount to survey as part of this scheme, and we've tried different things, but there have been issues with getting survey as part of the project, but that has been part of the problem with W1A being accelerated and ahead of everybody else, and probably the survey program. And that's it. Any questions?
There's no questions as yet, Richard, that I can see in the chat. If anyone's got any questions, I've got one myself. Do you have any details on the geocells that you talked about, the transition to the deck? Have you got a design for that?
I haven't got anything to hand, but basically, because this track with exceptional values has to have, belt and braces. We're basically putting everything we can on it to keep its alignment, and that was one of the RAM's requirements, is that he wanted it to be drained. It has to have all of the geotextile geogrid. So when we spoke to the Vente, he was less concerned about having geocells all the way through the embankment. However, because it overlaps with existing embankment and proposed embankment, by putting geocells in next to the structure until you get onto the new embankment, then the geocells would basically provide a uniform track stiffness under the track bed. So that's the only part of the project where we've used geocells at the moment.
Okay, thank you. Anyone online? So Peter Halliwell just asked a question. So 38 years ago, I started my railway career at Miles Platting Depot, which was located at the back of the sidings there. Do any remnants from the depot affect the structural design and installation process?
Yeah, I think there's been impacts on the structural design. So there's subways, like filled in subways underneath this site, especially around, as you say, Miles Platting. There was structures in there that have been infilled underneath. So we're having to do temporary works. We're having to strengthen where we're putting the embankment in, we're putting quite a lot of strengthening in that area immediately next to Queen's Road structure, the new structure. So yeah, there is a lot of history in there, and one of the reasons again for the geocells is because buried under the current embankment is a retaining wall. So having to break that retaining wall because it would sit directly below the track. So having to take it down a metre, as before they built, well, they've actually built the embankment now, but whilst they're building the embankment. So yeah, there's a lot of stuff under there that you wouldn't necessarily know about unless you went to old maps.
Okay, well, yeah, that's a good point. James Carney said, when will the new alignment be brought into use?
I mean, we're planning, obviously they're out there now building the embankment. I'm not entirely sure when it's coming to use. It changes regularly. I believe we're building this in 2021. So obviously it will come into use shortly after that. Whether the speed increase happens at the same time, I think that's going to come a bit later once it's constructed.
Okay, thank you. And Vladimir's got what savings in time achieves, say for the section from Victoria to Stalybridge. Can you talk about that, about the time savings?
Yeah, so time savings, so for this section is 43 seconds. Overall, I think they were trying to achieve about 9 minutes off the top of my head, I can't remember. But there's some areas that are very similar to this where they've got dips in speed that just make a huge impact on time saving. Morley Station being one where it's on a tight curve as it comes out of the tunnel. So yeah, overall there's I think it's about 9 minutes. If anyone knows on the call, then let me know. But what's piece of electrification being installed whilst it's being used. So no, the electrification currently goes up to about chainage 700, I think, as part of MWEP, and then it's been then designed as part of this project to go all the way around to Stalybridge. So it's being designed as part of this project, basically. Yeah.
Vladimir, come back with another question. Do they use micropiling over a method to keep the embankment ballast?
No, because it's brand new embankment, they'll just construct it like as they would normally, compacted layers. So it's on good ground. It's being designed to be fully drained, so that's been factored in the design. But yeah, there's nothing special. Drainage is a problem as usual for tow drainage, but for the track drainage, which is all I care about, it's free draining. Okay.
Okay. There's no other questions. I'd just like to thank Richard for taking the time out. He's obviously keen on some of the working hard on some of the works here. I think you phrased some good points that I've jotted down that I probably might have a chat with you about later. But a key thing is predominantly, there's a key message there. If we can get the good asset data for any scheme, that's going to make work a lot easier going forward. But if I can ask people on the call, I don't know if we can, Sarah, if you can unmute people or not. And here we are, round of applause. There we are. Keep going. Go on. Round of applause for Richard. Thank you very much. Thank you, Richard. And thanks for everyone attending today. We've got the next meeting, I think, is on the 19th of November, and it's all being well, it's traction decarbonisation, and that's Stephen Hart from Network Rail, who kind of pointing the way with what we're trying to do on the railway. I think that's about it for today. So thanks for attending, and have a nice day. Thank you.
Cheers, Dave. Thanks a lot.
Thank you.
Yeah, thanks.